So I'm here to lecture to you about a project. It's more project than a single research, which is a combination of two crews, one from Japan and one from Israel, and sponsored by both ministries of science. And the aim of this project was to design evacuation or framework for evacuation plans with emphasis for tourists, because usually tourists are in more risk or more vulnerability for uncertainty. First, just to emphasize the few people that works on this specific study, which we also sent the paper of. From the Japanese side, the research director is Jan-Dirk Schmucker. From the Israeli side, it's Yuval Adas. Under us are Boaz Ben Moshe from Ariel University on the computer science area in Israel, Oren Nahum on the optimization part. Yohan Gao is a PhD student which deals with all the behaviors, tourist flow, econometrics sides. And myself, I am a postdoc in ELFCOM laboratories in France at the moment, in Metz, France. And I dealt with the simulations and parts of the modeling and designing the framework as it is. So just without further ado, just to speak about the background, because I don't have much time and this project is full of experiments in it. The idea is that the number of tourists in the pre-COVID era, pre-Zoom, before we were in these boxes, this number of tourists was increasingly, the amount was increasing worldwide. And with that also the safety concern. And because of that, the concern was becoming very, very vast. It's not was only for one areas, and we needed to deal when thinking of a big framework of many, many things like typhoons, earthquake, everything that were mentioned earlier in this workshop. Terrorism also, war zone. I come from Israel once in a few months as we have some clashes, tsunamis, and recently, you know, virus outbreaks. But we were really, really surprised when addressing the literature and when looking with our governments that there are no clear protocols to how to deal with tourists, especially on the first stage, like a disaster happened, what can we do? There was no clear protocols. After a day or two, there are protocol of evacuate tourists outside of the country, but not for the first stages. And this gap made us to think, okay, how can we improve this issue? And of course, one of the first things that comes to mind, it's the new technologies. The new technologies that we've seen in previous sessions that helps a lot to analyze disasters can also be very helpful for clustering different type of pedestrian people, residents and tourists, and to address them differently. And for that, we will have to put in our framework all the things combined, all the things that were mentioned earlier, but also how we treat the tourists differently and maybe how we bring the data back to them. Because this is the weakest link. The tourists are more vulnerable to get the data back to them. So, because this is a big framework and I will not address one specific literature, I will not go deeply into it, I will just say a word about everything. Tourist vulnerability was addressed mainly in specific cases. Here it's an example about hurricanes that tourists were not able to get the messages. They didn't know the language of the area for this example. General evacuation, of course, is widely addressed. There are journals just for that, workshops just for that. Tourist perceptions, again here, for example, from hurricanes. The tourists that got the messages were not able to understand what is the actual risks, what are the risks that they are dealing with, and many of them decided not to evacuate, even though that they were in a disaster area. Tourist flow patterns, those are commonly studied in regular time, Of course, these have a lot of influence economically, financially. You need to plan your urban area based on that. If you want to build a shop, you want to address crowd or anything. So those patterns are very, very important. In this specific research that we see here, they built it based on social media data, which is the latest trend in this field. And it is very effective because people just voluntarily give you the data. Tourist evacuation planning, not much research about that. Most of them deal with how to evacuate or how to build different routes for the pedestrian tourists, but apparently they also don't give the information back to the tourist. And as I said, this is the weakest link. This is the things that we want to add to the framework. This is what we think that will make this all literature to be one framework that we can give as a framework to the authorities to improve the evacuation of tourists, mainly in areas that are attraction for tourists. So the framework is based on route choice estimation and monitoring or getting information about the locations and flows. Both of those blocks in the frameworks get data from, you need to get the data of demands. You can have many kinds of data, as I will discuss later. And from those two blocks, you use them to improve the guidance, to send the information back to the tourist in order to make it more efficient. So I'll start immediately with the route choice estimation. So we get data, as I said, it can be from Bluetooth, Wi-Fi sensors. What I want to emphasize is the use of new technological methods to get this data, because by that we can find routing, how it changes, how it differs between tourists and residents, and also different behaviors. And we can clusterize them and understand exactly how they will act in time of crisis. I will give an example. It is a different example than the one I used in our paper, because here I need a simpler one to demonstrate. So I took the Vardia neighborhood in Haifa city, where I was born. And a few years ago, there was a big wildfire in Haifa, and Haifa is located in the middle of the woods. And as you can see here, there is only one getaway route outside of the neighborhood, and the neighborhood is surrounded by forest, and in this case, by fire. And there was a specific moment of panic where a group of high school students were traveling in the forest, and they got to the area over here. They were basically at the end of the neighborhood, and they needed to find the way back. They were far from, they didn't know the area. They come from a different part of the country, and they needed to find the way back. And let's look on the process of how they thought. So assume that they have a GPS app that have all the risk, all the accessibility issues, everything important. Then you will get a shortest and safest path from where they are located to the safe area here on red on the side. Of course, they don't have this kind of an app. And that means that they have much more uncertainty. So they start to go from the forest into the neighborhood, and they go to the first intersection, and then they need to decide, go right or left. See, look at it already on the map. It is not very clear where you need to go if you don't know the area very, very well, even though that it's not a very complex network. And when, assuming that they got the wrong way, it means that they go directly into fire, and it is very riskful. If they got it right, again, it is not very clear what they happen, and the risk of doing a mistake is very, very hard. And those risks at the intersection is something that was not really addressed before in transportation, mainly in evacuation. They usually pick wrong wrong safe zone decision or wrong path decision, but we make it the mistakes and the uncertainty and on the intersections, and that makes solutions and simulations for this kind of settings to be much more difficult and computational demanding, but it is much more real life close. So again, just for you to understand what I'm talking about, I'll took a very short video, a few seconds. Think, do you know the general direction? Do you know the language? Are there even signs over there? Do I know if I've done a mistake? Is this a short path? Is this a safe path? Do I even know where I need to go? And imagine to yourself that the whole sky are full of smokes. You cannot see where the fire is coming from. So basically here you can see there are no signs. Even if there are signs, they are in Hebrew or Arabic, which means that if you are, I guess, from most of you from Japan at this time, it means that you will not be able to get the idea where you need to go. So that's about the mistakes, how we define mistakes in this case. Another thing that we got from the empirical data that we found is another insight are the behaviors, and those are just some of them. And again, I'll show by the example. So let's assume that we again got to the second intersection, and in this case, we took the wrong path. In the case that these groups of students were cautious and they understood, okay, we did something wrong, they will go back. But maybe they are riskful. They said, okay, we did some distance. Maybe now it is shorter to go further ahead. So they take the risk and they continue forward. As we saw earlier, this can be very dangerous. And of course, combine that to the knowledge, the premier knowledge that they have about the area. Maybe they don't even understand that they have a mistake. Or maybe they will get this insight or this understanding after 500 meters, 1 kilometer. And by that, we can, only that shows us a lot of different behaviors that need to be formulated. Two things that we have done regarding that one is done by the Japanese group, Yuan Gao, the clustering of different behaviors, different type of movement using machine learning and econometrics. And another thing by Boaz Ben Moshe from Ariel University is they built a virtual reality experiment that they want to spread around the world, where people just go to places that they don't know and they need to find their way to the safe zone and to see how we can improve this way. The second part of the framework is the gathering information about the tourist location and flows. There are a lot of complexities in that. Dispersion of tourists, the information availability using the internet. I am, for example, when I got into a new place, I just opened Google Maps looking for the top rated, and in many cases, the places are outside of the touristic area, which means that the distribution of tourists, it's much higher than it used to be. And if you want to predict, you need to look on many things. Seasonality, all Japanese here know about the cherry blossom, which brings a lot of tourists to Japan. Events, I don't know what is happening currently with the Tokyo Olympics, but again, if it goes well, it means a lot of people that will come to Tokyo. And of course, from the negative side, virus outbreak, you know, it also has some influence. Even if you got tourists, they will come from a different city and not from a different country. Also different prediction types. The long term, the long dimension, it means that during specific season, we can see peak of people. It is more statistic. During lunchtime, we will see more tourists in a specific area of restaurant. Short time dimension, from the other end, is more about the individual level. If someone is at this intersection, what would be the chance that we will see him on another one? We need to understand the people that are in less traveled places, to understand the congestions, where it will slow the evacuation, and in regular time, and even more than that in crisis time. It is very important to understand those kind of things. The the scenarios also, we saw already on the presentations here, many different scenarios. And of course, it means that many different ways of planning to them. In sudden scenarios, example, a terror attack or an earthquake, we are limited in the ways that we can prepare tourists for the evacuation. We lack the ability to make fixed evacuation routes. We need to decide on them as quickly as possible to acquire the accurate and relevant data and to assign it to the relevant model. For terror attack, it will be different from earthquake. In earthquake, you would like to avoid old areas or places with high buildings. Predictable scenarios are more easy to deal, but most of them are not really predictable. For example, you can know about an area that have a risk for tsunamis, but in the case of tsunami, you don't really know how it will affect the area exactly. And by that, we get the short-time predictable scenarios. And then we can build our plans to attack this case. And we have the ability, in case that there is a tsunami alarm, we can alert the people as quickly as we can. And we have the benefits of that, but we need to understand very, very quickly what are the areas of risk and how to treat the people that are currently in the area. And of course, know about the network, vulnerabilities depend on the scenario. And by that, I said that the output that we want to bring back is output related to the network. We want to know the weakest part of the network, places that we will think that there will be overcrowded during evacuation. Maybe we can build few routes. Maybe we can find few safe zones to send people to gather in safe zones. We need information about the scenario. For example, I was in Kyoto during a time of typhoon, not a big one, but I tried to get information about what to do in a typhoon. I come from the Middle East. We don't have this kind of thing. It was very hard to get it. And of course, information about communication in the tourist specific languages can be very hard to achieve. And the data by which we can find all these things are, of course, surveys and social media, as we said before, for trends, where people go. Google Maps is excellent to understand where people go. Cameras and isolated sensors, again, very good for that. If they work during the time of crisis, you can tell also where people are located. Cellular data, Wi-Fi and Bluetooth sensors are amazingly important, not only for getting trends, but for the online solution, to get in time of crisis where people are to send back data to them. And that is basically the last part of the framework. What we want.
Two more minutes.
Okay, I will run off this. This is just an example of the gathering of the data from Higashiyama World in Kyoto, where 20 Wi-Fi pocket sensors were distributed. I'll just go directly on that. We can see here static data. Where are the congestion during the time? You can see that there is a path to the temple, entrance to the temple, and the bus parking during the work hours, during time tourists arrive. And about how people move, the flows, we get a matrix of where people go. If they are in node 4, we can know where, of course, in probability, where will they go from there. And this is very effective when you try to understand how people go. I have less than a minute, so the last part, and I will go extremely fast on that. We want to improve tourists. All this data help us for improving traditional routes. We can put signs in specific languages, send volunteers that know specific languages in places that we need. You can use landmarks and to address to them. SMS and push notification, and also apps and website can be modified to tell people in their own languages about where they need to go. We made some, and I know I passed in 5 bits, so just few experiments. This is about Bluetooth. You can see that we can get very accurate data, even a 3D data that also we can use to communicate with the person, tell him where to go. Rescuers can know where people are, and even if the building collapsed, they can know where people are located, which is very efficient. Simulation about where to put people. Here in green, you can see an optimization. This is where we want to put guidance, and in red are the safe zone. And we thought, if you don't have many resources, where you want to put the guidance. And how people react to notifications, which is, of course, very important. We want to know what moves the people. And a combination of that, an experiment of sending notifications to the people in order to avoid places with congestions. Those are just few experiments that we are doing at the moment. And of course, this is just a very, very short review. More of that you can find on the paper, and just feel free to contact us if you have any more questions after this, and if you want some collaboration or anything. Thank you very much. Thank you, and sorry for the times.
Thank you very much for excellent presentation, Guy. Okay, so for this papers, I'd like to invite Alif Sadao from Florida International University as a discussant. So are you ready for a presentation?
Yes, so good morning, everyone. Do you see my screen?
Yes.
Yes.
Okay,
Good
so
morning.
thank you, Professor Sekimoto, for the opportunity for getting this discussion along. My name is Arif Sadri. I'm an assistant professor at the Florida International University. This is 5:30 in the morning, so good morning to you all. Again, I'm going to talk about paper 5 of this workshop, planning for tourist urban evacuation routes, a framework for improved data collection and evacuation process. Mainly the way the way I read the paper, it's a planning paper, and as a very fascinating work, I'm going to talk first about my background a little bit, and my prior experience, last 10 years of evacuation modeling. And then I'll take it to the next steps to help the authors how they can build on what they have done so far. So as a brief background, again, as I mentioned, I've been working in the area of evacuation modeling for a few years now, and my research has recently been funded by National Science Foundation, USAID, USDOT, and Florida Department of Transportation. And I have looked into primarily the event, what we call here in the US hurricanes. And we have looked into hurricanes Ivan, Katrina, Sandy, Irma, and Michael. These are all major hurricanes that we have looked into, and we had real data from real people, how they have struggled during this time, and then what are the concerns, and then how when they actually went into the traffic network, what they have done to reach a safe destination. From household to the destination, there are many decision sequences. But when we talk about evacuation, there's a warning period, right? People receive the warning information. Then people try to react on it. So what we realized that we are not only dealing with the traffic network, we also have a communication network, and social network is part of it. So basically we're talking about the interdependency of social and transportation network, because people panic a lot, and whether they evacuate or not, this is the fundamental question in evacuation. Because a lot of time people, even under their imminent threat, they end up not evacuating. Based on our experience, actually 3/4 of the people that we surveyed from time to time in major hurricanes, they did not evacuate, but because of many reasons. So also we have developed agent-based simulation tool where we have integrated behavior side into the supply side. But because at the end of the day, from traffic engineering perspective, we are dealing with the supply side. We have limited capacity of the roadways, and we have resource constraints. So we need to understand the behavior and then integrate to the agent-based modeling so that you can treat the vehicle as agent as they're traversing the traffic network, so that you can understand the network clearance time. So again, this is an integration of behavior, like the demand. Once you predict the demand, you take it to the supply side to predict the clearance time of the traffic network. And I also looked into other types of hazards called like tsunamis and tornadoes. So basically, this is kind of my background. The reason I mention all this because, again, the framework that the authors propose in the paper, that's great, but there's some additional component that can be added if they want. First of all, let me um, uh, sorry, this was my second slide. So now I'm moving on to my third slide, where I'm going to highlight what the study, so in a nutshell, what the study has contributed. As I mentioned, they have studied tourist evacuation. So based on my understanding, this is a relatively understudied area. And tourists are, when you think of traffic engineering, we deal with level of service, the way people drive or the way people move in an area, right? Tourists are the more complex population group because they are not familiar with the area. And now during evacuation, imagine how much uncertainty they are facing with. So definitely looking into tourist specific population is very timely. I would like to appreciate the author for that. And in terms of the framework the authors propose, they are talking about two things primarily: how to collect information in real time so that the tourist location, you can identify the tourist location and the flow in the urban areas. And then how can you use this information for efficient to increase efficiency in evacuation routing. So use of data, and then how you use this data to better control evacuation traffic. These are kind of within the scope of this study. And as the author mentioned, the location is Kyoto, Japan, which is a very attractive to a lot of tourists. So it's a great area to study. And they have done some behavior models from empirical data. And then I enjoyed looking into the way they talked about sudden and predictable scenarios, right? Because for example, they need time before evacuating, right? If you have a family, right? Even if you're a tourist, if you have a family, if you have you have children, you have pets, your mobility, you have a lot of restriction. So now this is called mobilization time. This is the time you spend before you evacuate. And then what time exactly you evacuate and what destination you go. So the destination is also an important thing because people may have different destination choice. Some people can go to public shelter, some people can go to their friend's home, they can go to a hotel. Depending on the destination choice, your behavior is totally different. And then now once you know the destination, there are many ways you can go to that particular destination. You can walk, you can take a bus, you can take a train. So there is also a sequence. So basically, from the location of the threat where you plan to evacuate, you have a
Two more
sequence of
time.
decision to make. So 2 more minutes. Okay, thank you. What I'm trying to say is basically the framework that the authors proposed and the power of data. I think there can be a better alignment to the sequence of decisions that the evacuees make. That's what I'm trying to say. And also the alignment of the warning and response phase. As I mentioned, there is a social network. And these days we have social media. We had a great presentation earlier in this workshop talking about social potential of social media data, right? So now the author can better represent at what point social network or social media data can better fit into this framework to predict evacuation demand in a more efficient way. So the next slide I have, uh, I think I have covered the series of different types of events. So now, in some communities in the US, we have seen recently that it's not only hurricane, not only tornado, winter storm, there are different types of event in the same community. So the same community is being threatened by different types of hazard. So now, will the data be the same for all types of events? So if we can distinguish the data type for a given event, that would be great. And also series of events. Are you observing repeated threat, repeated tsunami, repeated hurricane in the same community? So then how the communities behave also important. And also shadow evacuation. Evacuation is kind of where it adds to the complexity. Why? Because shadow evacuees are the people who evacuate with being in a voluntary evacuation zone. They do not have to evacuate. But for the people who are in mandatory evacuation zone, because they panic, they end up being evacuating. So they evacuate for no reason. So that adds to the complexity. So how would you go about solving that problem? And, and the last point I have here in this slide is that, again, existing traffic, we call it background traffic, right? It's great that your data can predict evacuation demand, but now if you are focusing on tourists, how you deal with the existing other traffic, because for the tourists to evacuate, they are being added to the existing traffic, right? How would you predict the non-tourist traffic, right? That's what it might be good to add to that. And that's all I have. And I'd be happy to take questions. And I'll give the floor to the authors back. Thank you.
Thank you very much, Arif, for the useful comments. So, Deepansh, could you share the screen of the Menti?
Sure. Professor, there is just one question for either the discussant or the presenter.
Oh, I see. I see. Okay, so Guy,
Yes.
could you answer the question
yes.
from the audience or the Arif?
I'll do it quick. First, about the mutual aid. Of course that they can be activated. That need to be how you define the mutual aid. You can define mutual aid as inside the community, which is an issue, and you can define that by between cities, between countries. For example, in the aid of getting tourists outside to the nearest other country or the nearest city. So it needs to be addressed how we are doing that. But that's, of course, this is because we build a unique framework, general framework, and each country or each region that will take it will need to modify it. So if mutual aid is available, of course they should use it. In case of the coronavirus, mutual aid during the crisis, the most crisis time where I'm located, they similar things. They just started to get people outside of the area to in my case Germany. Okay, but even if they're not German citizens, just to get them outside of the area. Regarding the great comments of Dr. Sadri, thank you very much. You were basically right in all of this, and even about a few things that we need to emphasize more. Usually when, for example, there is a tsunami alert or there is an earthquake, you don't have the availability or the ability or even the time to get into your car and to drive to a fixed place. And you will be, as you said, you will be in panic. We addressed more the first stage. Another example, in Israel, we have in some areas from time to time rockets falling down. You don't have time to get into the car and drive. You run for the nearest safe zone. That's the idea. In case from mud that falling from the mountains when there are heavy rain, you usually don't get into the car. You will run into the safe zone. It's more about going by foot over there, more about pedestrians. And in that case, those decisions, as I mentioned, are very, very important. And of course, it should be integrated with the regular, more predictable scenarios later on. After people are in the safe zone, in case that the scenario already happened, they will need to evacuate to a safe area. And in case it's a longer time before, in case of many hurricanes, you can, and in tropical storms, you can know even days before, then the field of evacuation is full of that, and then you would just want to address how to send the data to the tourist, and what data will make them to listen to you. This is another thing that we are looking for at the moment. And it is very important because, as you said, and as I showed at the beginning, the perception of the tourist to decide if they should be evacuated or not, it is very important, and it is not always as the authorities think. Authorities want them to go out, they sometimes think differently, and we need to think how to bring them the information in a way that will emphasize the risk and will make them listen to the authorities for their own safety, of course. That's all, I think.
Okay. Arif, do you have any other comments?
Yes, of course.
Just one quick follow-up, Guy. Thank you so much for clarifying those things. So, but do you think the framework that you proposed that would also be applicable to local residents, not only tourists? So how do you think?
Yeah.
What will be the difference?
Thank you. I forgot to answer that. You asked to define what tourists are. For my example in Haifa, tourists were just people from another city. They knew the language, of course. So there is a spectrum, what tourist is. I went to Paris with my cousin, and she needed to show me the way to a place, but she was from another quarter, and it was very difficult for her, which means that she was a tourist in the neighborhood. And that means that we have a spectrum. And this spectrum changes the characteristics, the behaviors, the risk for mistakes. And by that, of course, you need to address each part of the spectrum differently. A person from a different continent with a totally different language will not be able to read the sign. A person from the same country, he will be able to read signs, for example, but he will not be able to understand very quickly where to go. So that's the issue. We need to define that, and this is one of the things that we are doing. It's the clustering. We take all data that we got, pedestrians and not pedestrians, tourists and not tourists. We can define them by the vendor's ID on the Mecca and on the cell phones, for example, and to try to understand what is this spectrum and how we can cluster and how can we maybe divide the spectrum in order to give best solutions to all the type of pedestrian in the area. Is that answering your question?
Yeah. Thank you. Thank you so much for that. Yeah.
Thank you. Thank you very much.
Thanks.
Okay, perfect.